Yeah, so quick presentation here on the upcoming release of mod security. So as he just said, Felipe is the lead developer of mod security, but he couldn't come because he's in Brazil and the weather there is great. So he said, nah, not this time. Just a quick agenda. And that's me. I'm a member of the Spider Labs research team. We're many different teams inside the Spider Labs research, but I'm focused on the web server security. And the team works with WAFs. There's two WAFs. There's the TrustWave WAF, and there's mod security. I only work with mod security. I also contribute the core rule set, which is the most common rule set for mod security if you ever used it. And I work in different roles before that, and that's where I met Felipe. That's Felipe. And he's also part of the team, and he is the main architect of mod security for the past 5 years. Yeah. So just a little bit of WAF. So there's many different industry names. So every vendor likes to call their own. But just when you see all those names, it's basically a WAF. And this is the definition that I like. So a WAF can be a virtual or physical appliance that prevents vulnerabilities in web applications from being exploited by outside threats. This is something nice that I like to put in slides. So by 2020, more than 60% of public web applications will be protected by a WAF. I'm hoping for that so I can keep my job. And just a quick overview of, I would say, the minimal features of a WAF. Anomaly detection, input validation, different security models, rule-based and anomaly-based models. And this one I just wanted to highlight a little bit because that's what the difference when you are looking for, let's say, a signature-based rules or just more generic rules like you have on the OWASP core rule set. In the sense that, whenever you get a match, you don't perform an action immediately. Like a block or something, you just add that rule to a score, and then based on the score that you define, you're going to decide in the end of the evaluation of the whole rules to decide if you're blocking or not. State management action, so you can track sessions and stuff like that. Response monitoring, and virtual patching, which is what's most of the commercial rules are focused on virtual patching, which in a nutshell is when you developed a specific signature to detect, let's say, something like the struts vulnerability, which everyone, maybe most of you are aware, that you detect a specific payload and then you block based on that. So mod security, it is, I like to call it at least as a Swiss Army knife of WAFs because it's very configurable. You're not tied to interface or something. You can just do whatever you want. You can run outside scripts when you're parsing rules and you're parsing requests and stuff like that. So if you're wondering like who's using mod security, these guys, and many of them are actually users that, or maybe customers from Spider Labs or just users that are active in the open source community for mod security. But many of them are also uses mod security as a backend engine. So, for instance, Verizon, Nginx, Kemp, Fastly, Cloudflare. So if you're using any of those services, you're using mod security in backend. And this also, at the same time as I'm proud seeing this slide, I'm also very concerned every time that I push some code to GitHub because I might break something. So mod security in a nutshell, at least for version 2, it is an open source file as a application file. Currently, we have support for Apache, Nginx, and IIS. So for version 2, it was a web filter module for Apache, and basically every other version like Nginx or IIS was using Apache underneath. And this is one of the reasons that we don't like, at least we wanted to rewrite mod security. It is the most widely deployed WAF, as I mentioned. So we have this data from a few years ago, and we know that is probably much more these days, specifically because, as I mentioned, there are many vendors using mod security in the back end. So just like very quick of the basic features of mod security is being able to decode and identify file uploads, parse JSON, parse XML, and this kind of stuff. So you can easily use mod security rules to check for a specific payload or specific data set inside JSON or XML. And being ideal for virtual patching. Well, it is open source. It's amazing. I'm not going to go over any details. Like, I assume most people know what open source means. And I'd just like to highlight that there's no upfront cost, but it doesn't say that it's going to be 100% free, because you have to, it's not like a set and forget. You usually have to spend some time tuning and configuring for a new environment. And now application file is just as good as the rules, right? So if you don't have proper rules in place, you're not going to have maybe the protection that you're looking for. Well, it doesn't offer some. So there's no rules from mod security itself. It's the engine. So you have to get the rules. We usually, most people use the core rule set, and it is great. I'm not sure if many of you or some of you used mod security in the past, but there was a major release of the core rule set last year, and it's much better now. Like the false positive rate, it's now it was reduced at like over 90%. So it's working great. I really recommend at least trying it out. There's also the commercial rules. So some vendors provide commercial rules. Spider Labs also do. So please buy rules so I can keep my job. And they're great because you don't have to. So the core rules they are easy to deploy, but it's not supposed to prevent all kinds of vulnerabilities. And the commercial rules from many different vendors tries to do that. So there's no graphical user interface as well. So it might be so the learning curve can be a bit intimidating at first, but the flexibility that this provides, I think it's better. But there are third-party tools for that you can try it out. I can't name all of them because there's many, but yeah. So there's no development platform as well. So you have to develop rules mainly using CLI. Okay, so mod security is so cool, like rewriting it from scratch, which is what we're doing. So there's a few things, and if you look at here, it's the current architecture for mod security 2.9. So if you're using, for instance, mod security for IIS, which is great, but for you to deploy it, you have to have all those intermediate layers over here. So for instance, you have to have Apache and mod security Apache module on the left side here, the lib Apache runtime. So even if you're not running Apache, you have to have those all libraries and components on your Windows or your, let's say, Nginx web server. And this is something that caused issues and other dependencies that we just didn't like. And one of them was So we had a release of version 2.9.2 for mod security 4 months ago, and I had to rebuild the package for IIS, and it was so because of those dependencies, it was a bit of a headache. So you see, like those green lines over here are all the dependencies that you have to be able to compile mod security. You know, so yeah, and just getting Visual Studio working was like 2 days of work, maybe. But yeah, you have the package ready. So if you want to put mod security on IIS now, it's easy. Just download the package. But then if you want to get the bleeding edge version, you know, with maybe some other features, you have to compile yourself. So you have to go through this not very nice process. And for Nginx, we don't recommend. If you want to use mod security for Nginx, we recommend you to go for version 3, because version 2 is simply not stable enough. We had many issues, and some of them was because of this dependency, you know, over Apache. And yeah, don't use it. Go for version 3. So this is mod security version 3. We had a release, pre-release candidate over 1 year ago, and we had a release candidate 2 months ago, and we are looking to release a gold version, hopefully this year, but it might be pushed to January. We don't know yet, but it's pretty stable. We have, you know, there's many people using it already. Especially for Nginx, if you sign up to Nginx Plus, for instance, you have libmod security already embedded there, easy for you to use. You know, have support from them. So we had good feedback. So the big difference here is you don't. So if you see, like you don't need this middle layer here, the mod security standalone, which was a warper between the previous version, and you don't need the mod security Apache module anymore. And you don't even need the Apache runtime library. So you take many layers and many complexity, you know, so it's much better. You still have these dependencies. Some of them are mandatory, like lib injection, which is what we use to detect cross-site scripting and SQL injection. It works pretty well. And Perl compatible runtime for the regex, it's also mandatory. But the rest is it's not, so it's optional. So it makes it a breeze. The idea is that, you know, so you have the Apache connector or the Nginx connector or the IIS connector, which is basically we call it connector, but it's basically like a module or add-on or something that you configure on your web server, and this connector talks to the library, and that's it. So that's the installation process. I just wanted to describe because it's really easy. Like the first step there is just downloading, getting your compiler and basic dependencies. And trust me, if you follow that, it's gonna work. So there's no headache. You know, it's very very simple. But that's for the library. And this is just a simple. Yeah, okay. So this is a simple example of a mod security connector. So basically here you're including mod security headers, and then you're instantiating on the variables. You have your configuration file over there. You're calling the mod security functions to check the URL, which is in this case is hard-coded because it's just a simple example. But it's just to show like how simple it is to, you know, have your application or your web server or whatever it is talking to mod security. So on the right side there, you just have like a simple mod security rule. It just is use lib injection to detect a cross-site scripting XSS on the arguments from the request. And if you copy and paste this code and run it, this is what you're gonna see. So So over the top there, you can see like it detected cross-site scripting, and then this is the debug. Sorry, this is the debug log from mod security. So that's why it's so verbose like that. So I have a quick demo here, and yeah, let's all pray. Okay. Yeah. Oh, okay. Good. Is it okay? The size or? Okay. So here I'm just pasting the rules. This is just basically saying to spit the bug log to SD out. That's the rule there. In this case, it detects SQL injection, actually. So. Well, if you're familiar with mod security, those rules should be easy, but yeah. So if you just look at it, like in this case, the request, there's no arguments, so it's just basically say that rule return 0 over there. It run the operator detect SQL injection. In this case, I run it again with argument of A equals B, and again, it has seen the value over there, but it hasn't detected the SQL injection. And now, just gonna put like a potential SQL injection payload there, and it instantly detected. So this is a very simple example, but just showing like how easy it is to write a connector for mod security. Okay, demo gods were nice. So can you make it simpler to extend? Yes, that's one of the reasons also for libmod security. So in this case here, we are using Python bindings for libmod security, so you can interface with mod security from Python. So if you don't want to code in C, if you're afraid of C, like I am, you can use Python for that. So if you want to create like maybe a web interface for mod security, or whatever, if you want to create your own CLI tool to manage mod security, you can use that using Python. So this simple script here is just instantiating mod security, loading the rules from a file, and based on the number of mod security phases, printing the rules for each phase of mod security. Phases is, so there are different phases for mod security. One of them is processing request headers or the post body or logging and stuff like that. Yay, my Python code is running. And so yeah, it's basically dumping the rules there and showing the rules ID and where it is located. So it is based on Swig. So if you want to maybe create bindings for other languages like, I don't know, maybe Ruby or whatever, it should be simple to do that. This was also available on version 2, but on version 3, we're making some improvements. Actually, last week, Felipe spent a lot of time tuning and pushing some fixes and improvements for the Lua interpreter. So the idea with Lua, it's different. In this case, is the scripting engine. It's not like the bindings that we have for Python, because for Lua, the idea is that every rule that matches, are being every request that gets analyzed, you can run a script in Lua and it's pre-compiled in the sense that you're not going to have all the overhead of maybe calling some external bash script or whatever. So it is integrated inside libmod security. So you can just do anything. So in this case here, it's a very simple example, just getting the variables from the request, looking for the arguments, applying the transformations to normalize data, and then looking for a string with script, and then returning on the logs suspected cross-site scripting. So it's a very simple case, but just imagine you can do something like, okay, if there's a file upload, check if there is a potential malware or something, run some scan on the file or whatever. You can do anything you like. So we had written a code for just checking the Bitcoin, the price of Bitcoin, and based on that, change the behavior of mod security. You can do stuff like that. Yeah. So can you make it faster? Yes. So it's one of the reasons that, so for mod security, we have the concept of collections, and the idea is for basically tracking user sessions. So let's say if you want to check if a user is sending too many requests for a given URL or stuff like that, you can use the collections. But the problem with version 2 is that these collections are stored in a normal, it's like a database file. And it had some issues, especially for things like parallelism. So sometimes, have this database grows a lot, and we had tons of issues. I'm not going to get all of it, but we wanted to change that. And for version 3, we're using a Lightning memory database, and it has many cool features, and it allows concurrent processing, distributing processing over different systems and stuff like that. So this is already available, and we had good results so far. It is available since mid last year. We have more collection backends to come, and the idea here is, so we want to implement them, but there's just too much stuff to do, so we don't know yet when they will come, but it's basically community tuned. So if we see more users interested to see those backends, we can definitely prioritize, or if any of you are interested to contribute or whatever, you're more than welcome. So I just have a quick demo here for performance. Oh, yeah, that's what I want. Okay. So yeah, this is just, I have to make it a little bit smaller. Okay, so this is a comparison of speed of mod security on HTTP2. And the idea, so this picture that is loading is very intensive in the sense of like many megabytes in size or whatever. And you can see the difference here. So on the middle, we have pure HTTP2. And then on the right side, HTTP2 with mod security, with the core rule set, which are the generic rules. So they're very intensive. They use a lot of collections, there's many generic checks. So this takes a lot of CPU time. And for me, the difference is negligible, at least for my standards. If you think like how many, like the level of protection that you get just for putting the CRS, and that's HTTP 1.1. So it's pretty, because it's 1.1, it's making like multiple requests to get the file. That's why you have this major difference. So the video durations is like 56 seconds. That's how long it took. So can we make it safer? Yes, that's one of the goals as well. So for version 3, we are putting like unit tests and also regression testing for any new feature that we add. So every new commit that goes to mod security, it's mandatory to have regression testing and unit testing. So that's very cool. We're very proud of it. So if you see now, we have almost 5,000 tests in total for all the features and variables and transformations, normalization, and everything like that. And we are also fuzzing it. So there's a very cool blog post which was released a few months ago about the integrating fuzzing with mod security, and we're using, of course, American Fuzzy Lab. And this is something that we're very proud. Like it's been running for 140 days. And it's checking the core and some very major functions of mod security. And if you're not familiar with American Fuzzy Lab, it's a fuzzer. So it just sends, okay, I'm going to say random, but it's not the case, but just simplified data and check how it behaves, if it crashes and which path it crashed and stuff like that. So it helps finding bugs. So it's running for 140 days, no crashes so far. You can see on the right side, it had run through almost 2 million cycles and 30 different paths inside the code, and 0 crashes so far. So we're very, very proud of it. So if you want to get more info on mod security, like how to start, how to use it, and even some kind of support or involving the community, we have all those, different GitHub pages. So for the Nginx connector, for the Apache connector, there's the blog, the Spider Labs blog, where we post any new features and major stuff from mod security. There's a Slack channel, IRC, Twitter, whatever. And if you want to help us even more, come work with us. We do have a position for my team, in mod security team, and it's very nice. I totally recommend. Like it's getting paid to work with open source software, so you don't get that too often. It's very cool stuff. We have a lot of stuff to do. There's other positions open, and yeah, that's it. You have time for questions? No? Okay. So any questions, just, email, whatever.